Okay, in this presentation we're going to look at Markov chains and how they can be used to model transition probabilities in a banking sector. So in actuarial's banking sector, so you can tell that this is based on an actuarial exam that features R programming. This is actually based on a CS2B syllabus paper. I can't remember which one, but I'll write it in the description. This exercise develops a workflow for analysing and understanding how employees move between different sections of the bank. This is the actuarial bank, based on age-related transition probabilities. And the exercise on modelling employee transition probabilities helps to develop critical skills, particularly probability modelling. So in particular, understanding transition probabilities, where we learn how to model and interpret transition probabilities for different states based on historical data, and also applying Markov chain concepts to model and predict future states based on current conditions and transition probabilities. Okay, so this is the actual scenario of the question here. Actuaria's bank marketing team. A bank in the country of Actuaria is recruiting employees from different sections. Initially, it is compulsory to work for marketing section for 1 year. After working 1 year, they can move to either administration or training sections. On exactly April 1st, they have a choice of moving to any other sections. The probability of moving from one section to another is dependent on the age at the last birthday. So that's why this one's a bit more elaborate, a bit more complicated than standard Markov chain questions. From historical data, it is evident that the transition probability of a person aged X last birthday on April 1st is as per the following table, which is on the next slide. So let's look at this slide here. So the table is written in such a way that the diagonal probabilities, which all have this 1 minus term, are the complement of the sum of the two other probabilities on that row. So you don't have to write it out as explicitly like that. It's just to make it crystal clear that each row adds up to 1, which is essentially a requirement of Markov chain transition matrices. So let's just look at marketing. You can read the other ones in your own time. So the probability of staying in marketing is 1 minus 0.0025x minus 0.0075x. And again, x is age at last birthday. The probability of transitioning to marketing is 0.0025x. Okay, and again, x is age. Our transitioning to training is 0.0075x. Okay. So essentially, just rough guess, I'd say that a lot of people stay in their own sections. Just general impression from that transition matrix. So moving on to the questions now. What we have here is 7 questions, 7 exercises. A, create a vector with the state space of the Markov chain using R code. That's straightforward enough. B, consider two persons aged 30 last birthday and age 40 last birthday respectively, who are currently working in the marketing section. So that's two people, one 30-year-old, one 40-year-old. Construct transition matrices of the section change probabilities. Okay. Create a Markov chain object with the state space equal to your vector in exercise A and the transition matrices from exercise B. R packages for Markov chains may be loaded and used for the same. So essentially what we're going to do here is use the Markov chain R package. So essentially exercise A, B and C builds us up to building this Markov chain object. So exercise D, calculate the probability of transition for the following employees who are currently involved in working in the marketing section. Case 1, an employee with age 30 last birthday moving into training section in 3 years' time. Case 2, an employee with age 40 last birthday moving into training section in 5 years' time. Okay, and moving on to the next 3. E, plot the transition probability matrices in exercise D for age 40 years. F, set a seed of 250, simulate sequences of 250 states using Markov chain sequences function for both persons in exercise D. Compute the frequency of the states. And G, use a bar chart to plot the relative frequency of the state for age 30 and label the chart appropriately. Okay. So exercise A is straightforward enough. Create a vector with the state space for the Markov chain. So essentially what we're going to do there is we have three states: marketing, admin, and training, and essentially just create them as a vector. And we're going to call that vector employment. So there we go. That's a straightforward enough one to get started with. Just create a vector of those three section names: marketing, admin, and training. Okay, that's it. That's all we need. And we can move on. So you recall our transition matrix was a little bit complex. Okay, so what I'm going to do here is create some of these functions here just to help keep a nice tidy looking piece of code when we actually create the transition matrix. So these are little mathematical functions to just speed things up and keep things nice and tidy. M to A means marketing to administration, M to T means marketing to training, and so on. A to M means admin to marketing, and so on. So you get a whole sense of them there. So essentially, I'm just going to use these as building blocks for the transition matrix, which is the next step. So we have 6 little functions there, and each of them carry out a little mathematical function. In the first case, M2A, it is 0.0025 times x, and it just returns that. Okay. So here is our transition matrix, employment transition. So it's a function of x, and it will return a matrix when it is finished, and the input is age. So just working through it there, what we're going to do here is in the first instance set up a little 3x3 matrix, and in the first instance it's just going to contain zeros. Now we're going to call it M. And what we're going to do is work through each row of the matrix, M11, M12, M13, and so on. And what will happen here is it will populate the matrix with the appropriate values of x. Okay, so essentially, depending on what x is, let's say x is 30 or x is 40, it will just make the appropriate calculations and create the transition matrix appropriately. So you could take a moment there just to actually study it, but it's actually a fairly straightforward exercise, and it really is just to replicate the transition matrix for the appropriate age. Okay, and that's it. So we're going to use that on an ongoing basis. Let's push ahead with it here. So what we can do here is actually look at it try it out for age 30 and age 40. So the function is called employment transition, and the input is basically x, the age. So what we're going to do here is actually just set it up for 2 cases of the age, 30 and 40. So we have employment transition 30, employment transition 40, and we're going to save them as 2 objects. These are matrices: employment change underscore age 30, employment change underscore age 40. Okay, and let's have a look at them there just to print it out. The transition matrix for age 30, there we have there right at the bottom. So it'll be 0, for the first row will be 0.70, 0.075, and 0.225. Okay, so that's a 3x3 matrix, and it's the appropriate transition matrix for age 30. Moving on to age 40, something very similar there. Okay, so that's it. Yeah, 0.60, 0.10, and 0.30. That's the top row again. Okay, just to sort of compare and contrast. So essentially, depending on what the input is, 30, 40, and etc., etc., it will create the appropriate matrix. Okay, that's us done. Now, what we're going to do here is create Markov chain objects. So we're going to create 2 Markov chain objects, and Markov chain object age 30, so new object, Markov chain. States equal employment, that's the answer to exercise A. By row equals true, yes. And the transition matrix is employment change underscore age 30, and the name is just the name we're going to give this object is Markov chain underscore age 30. And again, we do the same thing for 40, okay, age 40 as well. Just as a remark, I'm using the Markov chain R package as directed in the question, and just above that line where it says library Markov chain, just in case you need to install it. It doesn't work, maybe you have to uncomment that piece of code and install Markov chain, the R package. Okay, So let's have a look at that. Let's just print it out. This is our Markov chain object for age 30. It has the same matrix values as in exercise B, but you notice we have the employment states as the row names and column names as well. Okay, so it's just actually the output of exercise A plus the output of exercise B has given us now a proper Markov chain object that we're going to use later on. And there we have it for age 40 as well. Okay, so we'll move on from that. So calculate the probability of transition to training section. Okay, so what we're going to do here is create a function here that allows us to use these transition matrices and rotate through them. Okay, so essentially multiply them sequentially for the appropriate number of times. Okay, so calc underscore prob underscore matrix. So the function here is the initial age and then the amount of years that you need. Okay, so we're told in question for exercise D that there's going to be two of these cases: a 30-year-old and where they will be in 3 years' time, and also the second case is a 40-year-old and where they'll be in 5 years' time. So the initial age in this case is 30 and 40, and the years is how many years down the line we want. Okay, so essentially what we have to do there is use the matrix and just multiply it by itself a couple of times, 3 years or 5 years. We're told that both cases that they start off in marketing. So that was the first state. So you see B is 100, okay? So marketing is the first state, so that's why there's a 1 there and a 00 elsewhere, okay? If they were in admin or training or something like that, we would have the 1 in a different place. Anyway, so for I in 1 to years, this is essentially a for loop. What we're going to do is multiply B by the employment matrix for the correct number of times. So the initial age plus 1 minus I. It's essentially just to actually give us the employment matrix at 30, then 31, then 32, etc., etc. So that's why that age, initial age plus 1 minus 1, if you try it out, it just actually gives the right ages, because if we use the index 1 to years, that means 1, 2, 3, which makes no sense in the context of the transition matrix. So it's just to reconcile years to the age the person will be in that year. Okay, and return B, just return the matrix. Okay, return the B as the probability or the state of the person in that year. So we're ready to go now. We have calc underscore prob underscore matrix. That's our function. And the inputs are the initial age and the number of years. So in case 1, for an employee age 30 last birthday, moving into training section in 3 years' time. Okay, remember, training is the third of the 3 sections in our setup. So prob underscore age 30 underscore 3 years, and we use our function there, calc underscore prob underscore matrix. 30, initial age is 30, years equals 3, and that gives us our answer. So we have a little output here. We've just taken the third value from our output, which is the probability that we are required. What is the probability they move into a training section? And the answer is 0.4583, so 45.83%. So this is the overall breakout. So I just gave the third answer here. So this is a more complete answer. There is a 36.25% chance they go to marketing, or they are in marketing. There is a 17.91% chance they go to admin. And there is a 45% chance they go to training. Okay, that's just the full answer. So the answer I gave in the previous slide is essentially the third of those values. And case 2, for an employee age 40, last birthday, moving into training section in 5 years' time. Again, we use the same setup. The calc underscore prob underscore matrix. Initial age is 30, years equals 5. Printed out, and we have an answer of 0.5659, etc., etc. So 56.59%. And again, the full breakout is as follows: For marketing, it is 16.81%. For admin, it is 26.58%. And for training, it is 56.59%. Okay. So plot the transition probabilities for age 40. So essentially this is straightforward enough actually. The R package Markov chain will actually do this for you there. So essentially just plot it there. Just name the object and just say plot. Plot MC object age 40 underscore age 40. That's as straightforward as you can get, to be honest with you. You can have a look at it there. I made it a little bit bigger. So it's essentially a digraph with the various transition probabilities indicated by the arrows. I'll be honest with you, it doesn't really come out that well on this slide. It's really something that really should be, look at on a screen and you can zoom in. But here on YouTube, it probably isn't great. But it's interesting to look at all the same. Okay. Yeah, we'll move on from that. Essentially, this is a visual representation of the transition matrix, essentially. Okay. So, exercise F. Simulate sequences of 250 states and compute the frequency of the states. Okay, so we were told previously to use the Markov chain sequence, and we're told to use 250 states, okay? And we're told also to use this seed of 250. So what we're going to use here, or do here, is Markov chain sequence 250 and the two object names. And then we're just going to collect up the results, okay? So, age, or sequence underscore age 30, sequence underscore age 40, and essentially tabulate the results there, okay? And that's straightforward enough, really. It's just essentially the frequencies of each state. It just runs through 250 simulations. So, there we have it. 68, 32, and 150. And for age 40, something similar, 67, 34, and 149. So that's it, really. Okay, a bar chart for the relative frequency of states for age 30. Okay, so I'm going to use lattice here. You can use ggplot or you can use base R, but I'm just going for lattice this time. So basically vary it a bit because there's lots of good R packages there that you can use. So the command is bar chart, prop table, that just turns our these into percentages or proportions, okay? xlab is relative frequency, y is section, just the x-axis label and the y-axis label and the title. So straightforward enough. This is really nice. I really like lattice, okay? And this is the plot we will get. Bar chart for the relative frequency of states for age 30, okay? And again, you just notice there it's written in terms of relative proportion. If you want actually just the relative frequency or the proportions, if you want the actual frequency, just you can knock out prop table out of that. Just use seek underscore age 30 directly if you want. Alright, this exercise includes all steps to create vectors, construct transition matrices, create Markov chain objects, calculate probability, plot matrices, and simulate sequences, along with bar charts to visualize the data. So it was a lot of work done there. Okay, we'll leave there.